Hello, boys and girls. Welcome to the Dow Academy Online Learning. We look forward to seeing you all back in class. But for now, stay home, stay safe. And remember to always wash your hands with soap for at least 20 seconds. Let's begin.
Good day, Form 4s. I would like to welcome you to our chemistry lesson on reversible reaction. First and foremost, we want to define what is a reversible reaction. It is a reaction in which the products can react together to reform the original reactant. A reversible reaction is indicated with a sign which has got two arrows. The other one, it is facing the forward direction. The other one is facing the backward direction. It is used for reactions which we call equilibrium reactions. Like, for example, hydrated copper sulfate, which is blue in color, can be converted to anhydrous copper sulfate plus water. And this anhydrous copper sulfate, it can be converted back to hydrated copper sulfate by adding water. And this forms a reversible reaction which is forward and backward. Right? And then I just want to explain again on the equilibrium reactions. They've got some particular features. There are 4 features that equilibrium reactions have. The first one, the reactants and the products must not escape from the reaction. We call this a closed system, which means as the reaction is proceeding, if it is a gaseous state, the reactants and the products, they should be in a closed system. And then the second one, at equilibrium, the reactants are continually being changed to products, and the products are being changed back to reactants. And we say that it's a dynamic equilibrium. And then the third one, at equilibrium, the concentration of the reactants in the products does not change. This is because the rate of forward reaction is the same as the rate of the reverse reaction. Then the fourth one, the equilibrium can be approached in either direction. We can start only with reactants or only the products. Whichever we start with, we end up with the fixed concentration of reactants and products in the equilibrium mixture. For example, when we heat hydrogen and iodine in a sealed tube, we form hydrogen iodide. We get the same concentration of hydrogen and iodine and hydrogen iodide at equilibrium when we start from hydrogen and iodine or from hydrogen iodide. And in a nutshell, that describes the features of the equilibrium when the forward reaction and the backward reaction, they are proceeding at equilibrium rate. And there is another important point that I want to highlight, that the position of the equilibrium tells us how far the reaction goes in favor of the reactants and products. If the concentration of products is greater than the concentration of reactions, we say the position of the equilibrium is to the right. It favors the formation of products. If the concentration of reactants is greater than the concentration of products, we say that the position of equilibrium is to the left and it favors the reactants. And that is how we can describe in a nutshell the position of equilibrium. What does it imply? What does it give us in terms of how far our reaction is proceeding? And remember, point to take note is that this should take place in a closed system, because once the system is open, some reactants, they escape, like gaseous reactants, they escape. But if it is in a closed system, all the reactants and the products, they are kept within the system. Thank you very much for your time for our lesson. God bless.